Then we'll talk about the underground mining methods. So underground mining methods are used when mineral deposits are located deep beneath the Earth's surface. Making surface mining impractical involves creating tunnels to access ore bodies. Why it is impractical? Because underground mining, they have minerals way beneath the Earth's surface, so it is not financially profitable to uncover the whole overburden and then go for open pit or open cast mining, because the overburden is so thick, it is totally not possible to, or even if possible, it's not financially profitable to extract the whole of the overburden and then go for the open mining technique. So that's why they use underground mining. There are a lot of hazards in underground mining. There can be poisonous gases inside. There can be landslides, earthquakes inside because of continuous extraction. They have to be very careful. A lot of security measures are taken in underground mining areas. So we have first the unsupported underground mining methods. So we have room and pillar mining, where horizontal ore bodies are mined by creating large open rooms while leaving pillars of untouched material to support the roof of the mine. Once the material is extracted, the pillars may or may not be removed. Okay. So coal, gypsum, and limestones are the one where room and pillar methods are useful. So you can see this one, where they do not use any kind of uh, say for example, they make shafts and all those things like lifts and all those things for other kinds of underground minings, but here for the support of wall um, they just leave behind some of the blocks of coals for the support of the roof. Okay, there is no artificial or no um any other kinds of methods they use for the support of the roof. Okay, they just leave behind some of the bars, some of the pillars, okay, for the safety of the roof. Simple design, effective for shallow deposits, only recovers a proportion of the materials as pillars are left in places. Okay, so they are room and pillar methods are mostly used for coal mines, where the coal mines depth is not so much deep, but mostly in the shallow areas, but still they go for room and pillar, where open pit extraction is not possible. Then we have shrinkage stoping. So ore is mined from the bottom up. Okay, from bottom up they go, and broken material is allowed to accumulate in the stope to support the walls and provide a working platform as the mining progress upward. Okay, so they mine and they keep the overburden here also, and as they elevate, they will keep mining from the walls. This is the working platform of overburden. This is the ores. So steeply dipping ores like zinc, copper, and lead. Steeply dipping ores means ore body should be dipping like this. This should be the ore body. Ore body should have a dip like this. And natural ore support reduces its need for artificial structure. So again, this is a natural support is there, where we are actually allowing the materials to accumulate on the stope to support the walls. These are the broken materials, or which are materials which are not needed. Okay, broken rocks. So disadvantage is very slow and labor intensive, requires good roof control. Okay, shrinkage stoping. If I find the good image, I'll show you. Okay, so this is a shrinkage stoping image. Okay, so this is done by like this. First, this one is done. This is left behind. Then again, they will go for this one. They will allow the broken materials to accumulate to go up. Okay, this is how it is done. And these are small channels which are made for um, the different trucks and all to go and collect the material. There's another image I'll show you. I hope you can see it. Yeah, this is shrinkage stoping. So blasted ore left in stope, and draw point is this one. Okay. So again, you can see this is the cross cut. Okay, perpendicular to the ore body. This is the ore body, and this perpendicular to the it is called a loading cross cut. This is perpendicular to the ore body, and this is the ore body. Fine. Now go to open stoping. So this process involves creating large voids to access the ore body. No artificial supports are provided, so it is often used to in stable rock formations. Okay, so stable rock formations are required here for this process to operate. Okay, stable rock formations are must for open stoping. So they use large voids. This is the stope, and this is the drill access, and no artificial supports are provided. Used for copper, zinc, and iron ore. Advantage is cost effective and efficient in competent rocks only, hard rocks, and not suitable for weak or highly fractured rocks. So coal is not the way. We cannot extract coal from this method, open stoping. Okay, we need hard formations like granites, maybe copper in granite. Okay, maybe extracted from open stoping. So this is an open stoping technique. So the image is not coming good, I think. Just let me. Okay. Yeah. So you can see here, this is how an open stope mining is done. Long hole drilling and blasting. This is the stope, and these are blasted ores. We have undercut. So it's like this. Okay. Open stoping technique. So if this question is asked in exam, please try to draw as much diagrams as possible. Okay. Description is fine. You have to give little bit descriptions, but drawings are must. Okay. Then we have sublevel. So we have sublevel stoping. A series of horizontal tunnels or sublevels are created within the ore body. Okay, they make lot of uh, levels or body to allow for drilling and blasting. The broken ore falls into draw points and is then removed from the mine. Gold, lead, and zinc are the minerals that can be extracted from this method, suitable for steep ore bodies, efficient material recovery. And disadvantage, it requires extensive planning and precise execution. Okay, just a minute. Okay, so I'll show you sublevel method mining. Yeah, this is a sub-level method mining. You can see two levels have been created, and they are drilling and blasting the rocks and then extracting those from crosscuts. So mostly they place dynamites here and then blast the nearby stope. This is a stope, and then they this thing is a stope. Okay, this whole thing is a stope. From where they have extracted the ore bodies is called a stope.